Okay, hello everybody. Welcome back to the Remix series, the Remix AR Bootcamp for Real World Impact. This is the penultimate workshop, the final partner workshop at least, before we head into the Build Week workshop, which will be coming up after this one. So this is a session with the graph about verifiable indexing for real world and clinical data. And then next week, of course, we have Build Week kicking off on the 8th of July, which will be the final workshop of this series, which will be led by Rob from the Remix team, who will shed some insight into there and what you guys should be getting on with and building. So far, hopefully you guys have learned a substantial amount about building different dApps with Remix, smart contracts, and the agentic payments with Base, dynamic oracles with Chainlink, verifiable AI with ZK Verify, and identity with ENS and Inscribe, which was a couple of days ago. Today, we have another crucial piece of this stack. So we are joined by Marcus, who's going to be talking about the graph and the big idea. So once your data is on chain, you need to be able to search for it, structure it, and trust it. And that's exactly the problem that the graph is going to be solving. We'll look at how it powers searchable, structured, verifiable data sets for public infrastructure, resource systems, and healthcare. And I think this will matter a lot to all your projects because it is, after all, real world impact. So I will invite Marcus up to be a panelist, and then we will get on with the show. And hopefully Marcus has a great little demo and a presentation to teach you guys all about this. So without further ado, Marcus, I think you should be able to unmute yourself. Welcome to the stage.
Hello. Can you hear me?
Hello. We can hear you, yeah.
Wonderful, wonderful. How's it going? Thank you so much for having me.
No worries at all. How are you doing?
Yeah. Doing great. I've had such good interactions with Encode Club throughout the years. And so I'm really happy to be here today talking about the graph and helping people understand the various ways to get blockchain data into a usable form.
Awesome. Sweet. Well, there should be a big screen share button at the share screen button at the bottom.
Yep.
Yeah.
So let's go ahead and hop right in. Yep. And are you going to stay on stage here? And I'm comfortable if you chat with me as we do this, or you could hop off, whatever you prefer.
I'll probably stay in the background, hand it over to you, and then I'll pop back at the end and give it a nice wrap up and everything.
Perfect. And then Rob, I believe, is here.
Yeah, I'm here. Okay. And David, Giles, did you bring on David?
Oh, yeah. Let me find him.
It's all good. I'll get started, and would that be okay, or should I hold off? Whatever.
No, that's fine. You get started. I've just invited David up to be a panelist, so he's now joining as well.
Okay. So I'm going to share my screen. And I'm wondering, can you see my screen here?
Yep, we can see your screen.
Okay. All right. So we're going to go through a workshop called Quick Start to Subgraph Development and Querying. We're not going to go through the full workshop because I want to take the time to really jump into the Remix IDE. So by the end of this, you should understand what the graph is doing, understand how to get blockchain data from various blockchains into your development environment and to start working with that in a productive way. And then also how to use Remix IDE to leverage some AI tooling to really accelerate your workflow. There's some new features that Remix has just put together, and I'm really, really happy to share that with you guys. In this call also we'll have Rob and David. Rob and David are also part of Remix team, and I'm happy to have them on as well. So let's get into it. And of course, if anyone here wants to know more, reach out to me on Twitter. I'm always available to help out. I can't see if anyone's holding a camera up on their phones, but I'm just going to assume that people are. And 3, 2, 1, we'll go through. So we'll start with an introduction to the graph. So starting with blockchain data, this is the splash page, the former splash page of thegraph.com. You can go there now. It's changed a little bit, but this is essentially a tagline we used for a little bit. Access the world's blockchain data. What does that mean? So kind of Access is doing a lot of work here. What does that mean specifically to have that data be in our hands and performant in a way that we would like it to be? Well, first thing that I would like to have when I'm looking at data, especially in the blockchain world, is understanding provenance, which is where did that data point start and what has it done over time, and how has that evolution occurred? And with blockchain, we can do that pretty dang well. Let's do that with this example here. This is just an example of looking at a storage of an NFT contract. You have the ID, the owner of that NFT contract, and the URI, basically the link, and it goes all the way through. This is just a CSV example of that, but not meant to be literal here. But when we have this is all just kind of itself, just rows and columns. We're not looking at the history. And that's really an interesting place of blockchain data, where we need to look at history, not just at a single data point and all the information in it, but how has that data point changed over time? And so to continue this metaphor, this is that same CSV file, but I don't know if anyone here has used the Apple history and the backup feature that it has, but essentially this is a visual example of that, where you're looking at a single smart contract and all the information on it, but what happened yesterday, and what happened the day before, and what happened the day before. It's really important to understand if we're going to be interacting with blockchain data, especially with the amount of blockchain data that's out there. How do we organize this? How do we query this? How do we get that data into our applications and provide useful either dashboards, analytics, or analysis on this? So enter a little bit more detail on blockchain technology. Blockchain itself is, of course, write optimized. We want to get state set there. But the read issue really occurs where we want to get that data to our front end and going directly to chain. I'm not sure if anyone here has done any ETH calls or called directly to a node. It works. We can get our data there. But at the same time, it's not as performant as, let's say, a Postgres database. If we had all that data in one database and we could just drop a query and then get that return, we have more productive time on our hands and the front end can be more responsive. So that's a real big thing that we wanted to do with the graph. How do we go ahead and take all of blockchain and put it into performant databases in a decentralized way? And so with centralized indexing, that's an option. With decentralized indexing of the graph, we have all these different nodes, all these different redundancies throughout the world operating for you to provide backups upon backups on backups to make sure your front end maintains performance as you are providing features and providing services to your clients and customers. So from there, we have truly decentralized apps being built on top of that. Now, a big part of this is the subgraph. So we talked a little bit about that decentralization and having many different nodes around the world, essentially providing a database that's readable quickly, as opposed to a blockchain node, which is not necessarily readable quickly. We have these databases in a decentralized way for the read solution. How do we tell these nodes right here what data we want? What smart contracts? What block numbers are we looking at? What block height are we interested in? What specific parts and stories are we trying to tell with this data? What data do we actually want? We have to give these various nodes around the world instructions. We call those instructions subgraphs. Subgraphs are essentially a way of saying, all right, well, I want this data here, this smart contract, this chain. Can you put it in a database here and expose it to a GraphQL layer that we can go ahead and query? And that's essentially what a subgraph is. This is I love this little GIF, not GIF of a live subgraph in action, where you take all the data and you go ahead and put it into nice database organizations. So from here, this is the part where I'll stop the slideshow. I think just a few minutes on this is enough before we actually get into code. And I can't see if there's any questions in chat at all, but I'm happy to answer if there are. Subgraphs are permissionless, customizable instructions for indexers, which are those people in the nodes around the world, to organize your data and put them in the database. So essentially, this is the pipeline. You have on-chain data and off-chain data, IPFS specifically, that can be indexed. But, excuse me, you are taking your on-chain data from, I think right now we're indexing 70, 80 chains. And you're looking at the subgraph.yaml, which is the manifest. It really gives the bullet points of what a subgraph should do. And then you look at the mappings. Let's say you want to take data from multiple smart contracts. You want to do some transformations and computations, some aggregations. You could do that in the mappings. And that's really, there's lots of features in subgraph mappings to do compute within your subgraph. and then finally present the data into a database. You're settling it into your GraphQL schema, and that eventually is your database. Now, where do you want to host this? Do you want to host this on your hardware and build locally? You can do that. This is all open source. Do you want us to host it at the Graph? We can do that too. We do that in a private area that has a private endpoint and is rate limited for free. But if you want that to be take that rate limit away, you can have us host it as well, and we decentralize it, and then that's where you have to pay, and we can go ahead and take away those rate limits, and you're on the decentralized network for all to see. So I'll stop right here. I wish I had multi-screen so I could see if there was chats. Is there any questions so far before or should I go back at all and explain further with anything? We're good. I'm not sure if anyone's saying anything, but is this mic on? Am I talking to nobody? Let's see.
There is one question in chat.
There's one question. Okay, I have a question. I see it. All right. Feel free to ask the question. Yeah, don't have an idea. Can we use Neo4j as a replacement? I haven't used Neo4j. I can speak well to the graph. And are you talking about replacing the graph as a whole? I'm not sure. Yes, I'm not sure on that one. I am not sure. I would say I'm almost, in terms of if Neo4j is providing a direct data, if you're looking at data to data and don't really care where it's coming from, yeah, sure. I'm sure if you can get blockchain data from Neo4j, totally possible to get it from there. This is an open source and decentralized version of it that participates in the query and indexing world in a decentralized way. We have our own token, we have our own network that's operating right now. So if you would like to go through that, that's what we are offering. And there are, of course, other competitors out there for data on blockchain. Hopefully that's helpful. So I'll hop right back in to this, and I want to go ahead and introduce the Remix desktop. And so there's a lot going on right here. I'm going to go ahead and close all of this, and we're just going to go ahead and get started with the fundamentals of the smart contract development. And that's fine. Okay, I want this closed. That's fine. Okay, so let's back up a little bit. Let's say we've developed a smart contract. Bam, right there. And this is a basic smart contract. It's counter.sol. I'm not sure if that's big enough for everyone to see. Make it a bit bigger. Zoom. Nope. How do we zoom? There we go. Zoom in. So basic smart contract here. It's a counter. So we're got a little counter. If we go ahead and hit this function increment, we add 1 to the number, and then we emit an event. And specifically, a subgraph will track this event, and we have that done well. So how do we go ahead and index this data point right here? When someone interacts with this function, we need to be able to put this into our database. So how do we do that? Well, right here with this IDE, this is the Remix IDE on desktop. You don't need the Remix IDE for what I'm doing here, but eventually you'll see all the features that Remix has put in and how this workflow really is optimized with Remix IDE if you're working on smart contracts. So stay tuned for that. So what we have is our smart contract. Now let's say we deploy that smart contract onto a chain. I've deployed this locally onto this Foundry Anvil instance. This is Anvil, if you don't know, is a local blockchain that's simulated. I've deployed the smart contract. I've interacted with the smart contract. It's had 8 transactions, and I've incremented multiple times. I'm not sure if the screen is big enough for people out there, but I've poked the smart contracts and this simulated blockchain. I'm working all locally here. That's really, really nice in terms of ergonomics. Now, from here, let's say I want to see what this database would look like. If I want to plug a subgraph into this, let's go ahead and do that. So what I did is I went to the terminal. Let's go ahead and open terminal with this. Terminal, new terminal.
You can see at the top near the workspace pull down in the top
Workspace
center.
pull down. Top
now
center.
move to the right there.
Bam, got it. Thank you. Thank you. So I had my terminal operating earlier, and I think this was it. where was it? Oh, here it is. There we go. Bam, bam. There we go. So I had my terminal operating earlier, and I was able to spin up a subgraph using graph init. Now there's a graph init, and then I'm kind of OG with this. I've been building subgraphs for years. I just said, hey, Claude, go ahead and spin up a subgraph for me to index this, and I want you to do this locally. And there's a little bit of documentation here. The graph local development subgraph. There's a quick start in here where if you go to the graph docs, and it is the GND. There it is. So GND. Local dev mode. Here we go. This is a graph node dev mode. All right. So a big request for many years was to have local development environment be part of developing a subgraph where you're all local. You don't have to use our services. You don't have to do other different parts of architecture. I literally just did Command A and I dropped it into my Claude. And that was the coolest thing ever because I've been doing this manually for years. And it spun up a local subgraph after I deployed that smart contract to my local Anvil instance. And it exposed an endpoint right there for me. It was like, done. And I was like, that's so easy. I'd recommend if you need this graph node dev mode, I'll drop this in chat here. Bam. That's really nice to essentially say, hey, get going and spinning this whole thing up for me in a local development environment. From there, I was able to start playing around with querying this subgraph. I've deployed the subgraph locally. It's running locally. Claude had it fully operational in literally 2 or 3 minutes, which is great. Now this right here is the, where is local.subgraph. This is a Remix IDE feature right here. I really like this, where if you want to now test another layer up, we started with a blockchain. We developed a little blockchain simulated smart contract, deployed it locally. Then we spun up a subgraph, a layer above it, and that's a little local thing that we did with the GND with the graph. And this is one level above it. Now we're into Remix feature here, where if you just create a .subgraph file, and then you point an endpoint at it right there, this is all local, and you can run a query, you can start seeing what that might look like for your front end. And we're getting a return right back. And this is the exact query that the exact interactions I did with that smart contract. I just basically iterated the number to 2, to 3, to 4, to 5, just by poking it. That's really nice. So right here, just in one IDE, you could develop your smart contract. You have the counter, which is really convenient. This is the counter. You could deploy it locally, which is really, really nice. You could have Claude spin up the subgraph locally. And then from there, you could go ahead and query from a very simple example of that query, all locally here. If you want to have more creative queries, this is where we're getting into the next features of Remix IDE. And before I push into the AI features here, Rob, is there anything that you would like for me to focus on this right here where we can develop our queries? Is this all good before we keep on going? Hopefully this is helpful.
I think so. Do people see that you just click the run query button to run the query?
Yeah, there's the run query button. Yeah.
Yeah, and I would like to add that if you want to also query the subgraph online, you can also do that by providing an API key. Yeah.
Yes, I'm heading to that right there. It's great point. And what you're listening to right there, everyone, is David. David is an engineer who did some amazing work building these features, and shout out to him and his work. I'm using it right now. So this is his feature and interacting with that. Really nice work, David. But yes, let's take that bridge and go to the next place. We've all been building locally here. I deployed a smart contract locally. I've got the subgraph locally. Everything's local. That's great, but blockchain is, of course, not local. it's all around the world. So how do we take this information and say, where does this go to the online world, to the decentralized world? What David worked on is exactly that. So let's say someone else has built a subgraph to index another smart contract, let's say a Uniswap subgraph, and it's a really well-designed subgraph. There's billions of queries millions of queries per year, billions of queries per year coming through it. It's on the network. It's not local here. It's out there in production. Let's go through that workflow. Let's go to the graph.com Explorer and see all these different subgraphs. So right now, in the last 30 days, this had 339 million queries on it, which is really, really nice. And so that's very much in production. This subgraph is querying a lot of information per minute, per second. But we have this little query here, and we could do a little test query on this subgraph that's on the Graph Network. This is in the Graph Explorer. This is a decentralized subgraph. I'll be clear about that. And it's in production. It's running in a decentralized way, which is pretty cool. What do? How do we go ahead and bring this information into our IDE? What we can do is take this little query right here and bring it in to our Remix desktop. I already prepared this into explorer.subgraph. So now notice we have a new, I'll close this right here. We have a new format where instead of the endpoint being local, I'll put these up side by side. We have local. This is my local endpoint, which is localhost 8000, subgraph's name, subgraph 0. That's what Claude spun up. This is a production subgraph on the Graph Explorer. And blah, 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 blah. This is the link that we have right here. If we want to hit this, this is the query URL, bam. And if you want, right there, you need to provide your API key into that little blank bracket right there. And how do you do that? You go to Settings, Connected Services, and then the Graph API key is right in there. You just simply drop that right in to send that query. So how do you set up an API key? You go ahead and go to, where did I have it here? I had it a second ago. Bam, bam, where is it? Here it is. Here's my API key. If anyone here sees it, please don't drain it. And then this right here, let's run the query, bam, running subgraph query, bam, and we got the data back. So this is now going to the gateway. Nice job, David. And now we have this information coming right through. And so we have block number, block color. This is a different GraphQL query. If you don't know enough about GraphQL, that's okay. Claude does a great job of creating some good queries here. But right now, we're querying a local subgraph and an Explorer subgraph, all on two different files. All it is just the .subgraph naming convention. That's all I did here. This file is very simple. It's at endpoint, and then you put the endpoint in there. And you just have to hit the Graph Network if you want, or locally if you want. Both work within the IDE. Now imagine this in a workflow. I love this as I've been working with subgraphs for 6 years now. Imagine this. You want to work with a smart contract. Is it local? Is it deployed? You simply go to the IDE right through here and you look at your smart contracts and you go ahead and, let's see, the compiler, the deployed smart contracts, you can interact locally, have a good time with that. Or if you want to go to, instead of a dev mode, you actually want to go to an actual smart contract, you switch your environments very easily. You can interact locally with the smart contract, or if you want to work remotely with the deployed subgraph, with a deployed smart contract. It's all in one IDE, which is, honestly, this is really nice because after multi-screening and multi-tabbing for years now, this is all very, very nice. And we really haven't even gotten into the next features that I really like about Remix IDE and the graph interactions, which is the AI kind of flows that are baked in, not just through the terminal Claude interface, but through their actual Remix AI assistants. So I'll stop there. Anything that you'd like me to go through, Rob, David? How are we feeling so far?
There is just one question that in the chat.
Okay.
Reader listened to a certain event. I think Chainlink runtime environment can do the same, but the difference is that the graph exposes an endpoint, right?
Chainlink runtime can do the same. The graphics, yep. I am not sure directly to Chainlink runtime environment can do the same. The graph does expose an endpoint, and that, if you want, what I always recommend for people to do as you're getting familiar with the graph ecosystem about those endpoints is go to the Graph Explorer specifically. This is the Graph Explorer, and look to see what index network are you looking for, which smart contract specifically. You can literally drop in the contract address right here and see if someone else has already deployed a production-ready subgraph. So you have to rebuild this data layer. And yes, an endpoint will be exposed. So let's say if you want Uniswap v3, and there's an endpoint right there, you could just go ahead and hit it right there. And you do need an API key. You could get your API keys in Studio right there, but you'll just hit it right there, and you get your data. And so hopefully that answers your question. Yeah. How are we going to see the node and edges based on the deployed subgraph? Specifically, you want to understand the index, the nodes, essentially. I'm assuming based on that question. If you want to see who's indexing this, you can go to indexers and you can see who is indexing this subgraph right here. I believe that's what you mean by the various nodes out there. Maybe that's that question. But yeah, anyways, yeah, we have 4 indexers on this one. So hopefully that answers your question. Can we represent it? Maybe, can someone help clarify that question? I'm not sure if I understand. Can only read a certain smart contract. Can only read a certain smart contract view function from my back end, just using the ABI and address. So my question is, what are the benefits of using the graph? I would say if you are able to do what you need to do, Chris NL, with what you have, wonderful. If you want a performant database to interact with, as opposed to using an ABI and going directly that way, it's just up to you. We're providing a set of decentralized databases that can run this infrastructure, that we run this infrastructure for you and provide an endpoint for that. So it's up to you on if you'd like to use it in that way. So I'm not sure if I answered that question correctly. How can we represent it? Sorry if I did not answer that correctly. But let's keep on going here. Let's get into a very cool feature of the IDE where, let's say we want to right click on this and we have the Explorer subgraph. We have the gateway built. The gateway query is right here, and we have the data that we want back, and we want to go ahead and actually build a example of this application just to get started. You could right click on that explorer.subgraph and create dApp from subgraph queries. It's taking a very basic little bit right here, basic query, basic thing here, nothing too fancy, but it drops a prompt right in here based on the data that it has, and it's spinning up right now. So that's really nice. Just answer these 3 questions. That's yes. One. Yes, that's great. 2, yes, and 3 defaults. And we'll let that spin up. So all in one app, you're able to pretty much build full stack from the almost as much backend as you can get, or blockchain as you can get. You're at the blockchain, you're deployed to the blockchain, and then from there going all the way to the front end right through here. It's a really, really cool interface. So that's the right-click Explore subgraph. It'll take a few minutes to spin up. And as that's going, Rob, David, is there anything you want to say as this is getting going here?
You could also query subgraphs in the Explorer, in the AI assistant.
Yes. So if you just drop in the
you can find out if a subgraph exists.
I like that. Does a subgraph exist for a Uniswap that has been, if so, list the most popular ones? I don't know. We'll see how that goes here. Is that connected to the MCP, the subgraph MCP?
Yeah.
Yep. Perfect. Yeah. So for those of you out there who want to go play with this AI assistant to get aware of all the different subgraphs on the Graph Explorer, this is we have an MCP server that's available, and you could access that directly in the IDE, which is another nice feature of your smart contract to subgraph to front end workflow. Auto accept, that's fine. And it's creating. So we've got the website right here. It also has the ability to do ENS, which is really nice. So you can go ahead and have this new demo application spun up and linked to an ENS address, which is a really nice convenience feature right through this IDE. And I think that's a lot of the cool features that this is just, I mean, this just launched today, correct, Rob?
Yep.
That's awesome. Just today. This is just today. So
you
really
should be
nice.
able to click on that instance as well and see what you get.
Right here?
Even if it's still spinning. Oh.
We got Uniswap, which is nice. We got the answer from the MCP server. It's really nice to be able to search through that. And I'm looking, where's the chat history? I'm looking to get into the other chat that I was in, the other chat window.
Oh, go back to chat history, which is that's no, it's not that one. It's back to chat. And chat history.
There it is. Okay, it's running. I think it's running.
If you go back to Quick Dap.
There we go. And here's the registration. So no files in the front end folder. Okay.
Yeah, I think we need to restart.
Restart the desktop?
No, not the desktop. I mean the dApp creation. I think when you switch the AI chat, it killed the session. Yeah.
I see. So let's restart again. Okay, so let's try this again. We'll go back to files. We'll start fresh. Where is this? We want explore.subgraph. Right click, create dApp from subgraph query. There we go. And I'll keep on this page. There we go. Sure. We don't have a front end folder, so I think that's the problem too. Front end. Let's just make a folder.
Oh, it should create it anyway.
It did it? Okay, cool.
It would.
Okay.
So
to no default. Let's say yes, I want to see a base mini app. That's fine. 3 defaults. And we'll leave this open and running. Awesome. So we'll let this run, and this will put this little mini app up here. I'll check for questions. All right. It's possible guest was asking about the DB and the built-in display in the front end. Yes. So that's essentially what we're kind of doing here. The example applications, in a way, do that what I saw earlier today did very much look like a database representation in the front end. It's not. I didn't know if it was interactive or not, but it did look like it spun that up. Listening to or some data can easily handle limit. GraphQL solve that. Does GraphQL solve that? Hitting the limit. Do you mean like a prompting limit, Chris? Or you mean rate limit? I'm reading your question here, Chris. Oh, well. Oh, yeah. So great question. So yes, so you're running into a rate limit issue that if you're interacting directly with a Ethereum node, eventually they'll just stop giving you data. Not so with subgraphs. With subgraphs, you could hit them as much as you want. They're the endpoints there. Hit them as much as you want. For the rate limits in terms of just go ahead and use a subgraph, whether it be local, whether it be on the graph network. None of those 100 queries issues. Good question. Glad we got to the bottom of that question. Thank you for being patient with me. All right, let's see how we're doing here. There we go. It's doing it. There we go. Okay, we got it. So we only gave it very basic data to build this application. And so it made a relatively simple front end, but that's, it was a very basic query. But it did it all the way through, and that's really nice. So the setup wizard, I know we're able to, here it is, app registration, dApp title, the graph remix demo app, and let's just go ahead and save next. App ID meta tag. Oh, this is for, okay. I said yes for that. So in the end, if I said no for that, that'd be fine. I'm not going to get the base ID mini tag. You could deploy this actual application and see it actually existing on an ENS and an actual website. Earlier today, there was a demo app shared. Let's see, did I get that? I'm not going to bring it out chat. That's bad OPSEC. I'm on live stream, but yes, eventually this will deploy all the way through. I saw this working today. I'd rather not redo this all once again, but the ability to get this online and to get this done with ENS is performance all the way through and able to be done. So that's pretty cool. Good job, Remix team. Essentially a one-stop shop for smart contract development, now subgraph development, and then also all the way to getting a front end specced out like really, really quickly. That's super impressive. I know that Scaffold ETH does it from its own way, more like plugins, but this feels more hands-on. This feels you're really in hands-on with the code and be able to customize every step of the way. I really, really appreciate that. So I'll go back to the chat, and Rob, David, you guys, is there anything you want to add to this workshop?
David, could you share? You could share the link to the subgraph you built. I mean the dApp that you built that was just querying a subgraph.
Okay. That'd be great. If you have that link, drop that in chat.
And then also if you can also have both a dApp that is querying a subgraph and is also interacting with a contract as well. Mm-hmm. So if you have a contract in the workspace, it will make the dApp for a specific contract and the subgraph.
That's very cool.
Yeah, I just dropped the link in the chat.
Very cool. So I'll just pull this up on my screen here. But literally built this just before this. This was registered on ENS and deployed. And it's a full stack application. We earlier today built from an ENS query. It was that .subgraph naming convention. And from there spun up a full stack application, which is kind of wild. So shout out to the Remix team on doing this. This is kind of wild to see how far this is grown into. So
actually, another idea is, could you try doing just making a query from the chat, from the AI chat, like
right here.
Yeah, like choose some random graph and make a query.
Sure. Please query the Uniswap v4 query subgraph with a valuable to gain insight on the last week. Okay. Excuse me.
Oh, also, you should note that we're using Claude 4.6. It's probably best if you're making a dApp that you choose that. Out of the box, it comes with Mistral, and so it's probably best to use Sonnet for at least making dApps and probably other things as well.
So yeah, it's getting to work right here. Good, rich schema. Query design, if you're not fully adept in GraphQL, that's fine. What Claude or any AI needs is, of course, context. And so that context ideally is the schema of the database. That's really helpful. So you can see, good, rich schema. It's looking for the shape of that database and how it's named and the different types of data that are in there. That's great. And now it maps that schema. And now, because it maps that schema, it's going to go ahead and run some queries against that schema, against that database, that hopefully will get back some good data. So future knowledge in case anyone out there is working with subgraphs or databases. And of course, give Claude or any, give your AI model awareness of the schema, and it'll do some great queries, be it SQL or GraphQL. There we go. Okay. So we got a snapshot, 7-day snapshot. Very nice. And I'll say, please share that query at the end here. It'd be nice to be able to visualize that. Still thinking. Yeah, I've been working. Remix was the very first IDE that I ever used, getting aware of blockchain. And it's really cool to see how much it's progressed. Anything else to add, guys? There's a lot there. We went over a lot.
I don't have more. Do you, David?
Sure. You have a question?
No, do you have more to add or any other? Oh, here's a question.
Yeah, I see a question in the chat. Yeah.
Let's go to the chat. Okay. Is the one of the main applications you guys want to manage users' transaction history? Managing, analyzing, think analytics, think dashboards, think you want to understand, maybe you're looking at KYC AML, you're looking for some type of security, you're looking for, you're doing you're looking for trends, any way you want to interact with blockchain data, specifically with events. That's subgraphs. Now, there's other tools and techniques and technologies in the graph ecosystem. Subgraphs are the one we highlighted today, but if you want even more simple, Token API is a great tool that's very simple. You don't have to spin up everything. We host everything. It's just a simple endpoint. You can get token data, wallet data. Events are not great with token data, with wallet data necessarily, but if you want to get that through our Token API, we have that. There's another piece of technology called substreams. It's basically the best way I can describe substreams is the enterprise version of subgraphs. When you are hitting a throughput issue with tens of thousands of transactions per second, sometimes, and needing to stay at chain head, sometimes subgraphs might slow down a little bit. And so substreams are really meant for that speed. There's a few other tools that we're working on, but go ahead and check out thegraph.com. For the most part, those are the developer toolings that are most.
I have another question. So if you wanted to develop a project that was there's 100 pumps that are with their meters are publishing data to the chain or to a chain, and you wanted to read what the history of the pump's output by day or something like that. Then what would be the process of developing a subgraph, just to kind of go through the steps?
Yeah, like this is already a deployed subgraph, for example, and the smart contracts already done.
I guess the first, assuming, assume nothing's been done, but just to step through the process.
Okay, assume nothing's been done. Like how to, like the architecture of a subgraph, and then like you want to go from that level, we can do that.
Yeah.
So let's say if I was spinning up a subgraph, I'd let Claude do a lot of the work. But if you want to go through the basics of a subgraph, let's do that, because that's cool, I think. So so subgraph, we've already deployed as. Let's assume there's already a smart contract deployed, and we're doing it manually. And you want to understand a little bit more of how a subgraph functions. The most important thing for a subgraph is the schema.graphql file. In my opinion, I think it's essentially the interface in which we will design our queries against. This is the database. So we're looking at a schema.graphql. This tells the subgraph how to name pieces of data and how to type them as they're coming in. This is a number change entity, and you can name it whatever you'd like. And this is a counter entity, and we named it the counter because it's counting the smart contract. Remember, the smart contract we had was a counter. Now, the most important piece of data that we wanted is this counter. So let's just break this down here. Every piece of data in the database needs an ID. So we give it the type of ID and the value of the type big int. So that's going to be 0, 1, 2, 3, 4, and change count. How many changes has it gone through? Another type of big int. And so this is essentially just naming what our database will, or how we'll organize the data as it lands there. And I look at the schema.graphql all the time as I'm getting familiar with a subgraph. That's typically where I go when I want to start understanding what it has. Subgraph developers, if you're developing and you plan to publish your subgraph, it's good to put comments out there just so we can understand what the purpose of this is. This little hash right there is nice to be able to see that in the GitHub code or on IPFS, where if we deploy this publicly, this data will go on IPFS. Now, let's go one lower level into those transformations. Remember, I talked to you about transformations in a subgraph. If you want, you can do them. You don't have to. But the mapping.ts. The mapping essentially says we've got this blockchain data that's coming in. We need to be able to use the ABI to actually take that into regular language, and then are we going to transfer and transform that code before we settle that into our database? So that's really what the mappings is for. So remember we talked about the counter. I'll zoom in here so you can see a little better. Just focus on this. We create a new counter object here, and it's of the type counter. We load in that type in here, and then from there, if the counter is null, if there's nothing in there, we create a new data point in this counter type, and we name it singleton. And then we just simply, this is the compute that we're doing. We're very simple compute. We're just a counter change count, big int 0, and we do the here's the counter change count equals plus. There it is. This is where the compute is. So this is basically checking to see if it's in there, and then if it is not, then we go ahead and change the count, and then we also add 1 to that there, and then we save. This is all in the database. And so if an event comes from the blockchain, we grab it, we check to see if it's in the database, and if not, we go ahead and run some compute on it. So from there, this might look like TypeScript too. This is assembly, so it's a little bit clunky in my opinion, but it works just fine. And then from there, the manifest is quite important for a subgraph. That is the subgraph.yaml. This is a .yaml. This is just basically telling us a super high level of what the subgraph's intention is. We have the address. We have the ABI that's being saved here locally. It tells us where we want to start indexing from, which is start block at 1, which is interesting. It should be 0, but this is Claude spinning this up. So anyways, it looks at the entities and also how we want to handle the events as they come through. If the event comes through, the number changed event comes through, then it triggers the handle number changed handler. And that handler is, of course, in the mappings to So from the lowest level, I guess, to the data to the transformations, to the overall shape of the subgraph, that's a subgraph.yaml, and then to the middle and to the lowest level, that's the database. I always like going to the database first, personally. So yeah, that's understanding a subgraph. And then from there, this exposes a endpoint, which you could have locally or we could host. And then from there, you can go ahead and query. Yeah, I'm not seeing any other questions. So hopefully I answered all the questions. Hopefully that was helpful.
Awesome. I think you have probably covered all the questions and everything as well. Thank you very much. Marcus.
There's a new question.
Oh, there is
and
another
I think
one.
that, oh, there's another one.
Oh, I see. How fresh is the
Yeah.
data? Great question. So depends on there's indexing is always, it depends. It depends because essentially it's all about performance. If you're running transformations that are super complex before they settle into a database, that's going to be more compute time, and that's going to be a little slower. And if you run very simple transformations or no transformations at all, it's going to be much faster. Also, if you're on a very fast chain and you're trying to catch up with a monad or something like that, that's going to be a very different chain than trying to keep up with Ethereum. So it depends. What I would say is if data freshness is a concern, go ahead and there's different testing suites out there for query time. I recommend just hitting an endpoint and seeing what that feels like for you. It is going to be different for each subgraph and each different use case. If your speed is really a concern, I'd look for a subgraph that is, but look for substreams. Substreams is going to be faster if you're with a super fast chain. For example, a subgraph cannot keep up with Solana. Substreams can. So if you're looking for that, go ahead and check that out. It's not exactly, both are not like MEV speed. Both don't have that level of speed where it's literally millisecond speed. We're not that fast. That's not our customer base. But we are quite fast with substreams. And what determines the speed? I think I went over that. Yeah, there's a lot of determining factors on indexing. So a lot of it depends. Chain speed, the transactions per second, the transformation time, whether you're doing event calls, no, not event calls, but if you're doing call handlers. So subgraphs and substreams can look at calls, not just events, but that takes a little bit more time. So there's all these little nitty gritty details. But just like a race car, the smallest of details make something go another mile an hour faster or slower. Same thing with indexing. Good question. But yeah, that's everything, I think.
I think so as well. Sweet. Okay, well, thank you very much, Marcus, for that great overview of the graph. Do you have any docs or links or presentations?
Yes.
Do you want to share them with me? Chuck them on our Telegram or something, and then I can share them with you guys. I'll put them on the Discord, so you guys can revisit these docs and resources that Marcus has shared, and then start to think about where indexing is going to fit into your own project for Build Week.
There we go.
So awesome, sweet, thank you. Nice. Okay, well then, looking ahead, I guess this was our final partner workshop, and before Build Week, we obviously have the Build Week workshop as well, where we are joined by Erin and Matteo, and Rob will be giving a bit more of an overview about that. That's on the 8th of July, so make sure you guys have locked that all in. Any follow-up questions to this, again, bring them over to Discord. I will share all the documents there over as well. And I think that's about it. Thank you very much, Marcus and EdgeNode and Remix and all you guys for this. And we will see you in Build Week.
Awesome. Thank you so much.
Ciao, ciao.
Thanks, Marcus.
Thanks, Rob. Thanks, David. Thanks, Charles.